Most of us know what happened to the Space Shuttle Columbia on February 1st, 2003. It was a national tragedy, a horrific accident that took the lives of 7 brave astronauts. But the story of how it happened, well, that's a lot more complicated. This isn't just about a technical glitch. It's really the story of a cultural failure. It's about how for 16 straight days, an entire organization, one of the smartest on the planet, completely missed the warning signs of a catastrophe. So let's dig in and unpack how this was ever allowed to happen. Okay, so let's set the scene. It's a Saturday morning. The Columbia crew has just wrapped up a super successful 16-day mission in space. Now, they're on their final approach, heading home. It's a fiery re-entry for sure, but this is supposed to be the routine part, the triumphant return. And then, at 8:59 a.m. Eastern, Mission Control in Houston gets this: a partial transmission from the shuttle's commander, Rick Husband. Just one word, Roger, and then silence. Those were the last words anyone on Earth would ever hear from the crew of STS-107. What happened next in Mission Control was just pure chaos and confusion. 1 minute after that cutoff transmission, every single piece of data from the shuttle just vanishes. The screens go blank. And then, 12 agonizing minutes later, the absolute unthinkable. A phone call comes into the control center telling them that a news channel is broadcasting video of the shuttle breaking apart in the sky over Texas. So what on earth went wrong? In the months that followed, a special investigation board was formed, the CIB, and their job was to piece together exactly what happened. And the physical culprit they found? It was almost unbelievably small. Yeah, look at that. 1.7 pounds. That was the weight of the thing that brought down the shuttle. It was a piece of insulating foam that broke off the external fuel tank just 82 seconds after launch. To put that in perspective, that's about the weight of a loaf of bread. And that little piece of foam slammed right into the leading edge of the shuttle's left wing. And right here, this is the central mystery of this entire story. How could something so seemingly harmless, so insignificant, destroy a multi-billion-dollar marvel of engineering? Well, the answer isn't really about physics. The real answer is found in the decisions and the non-decisions made during those 16 days between the foam strike and that final fatal re-entry. Okay, so let's rewind the clock. It's launch day. Engineers are looking at the footage and they spot the foam strike. Immediately, some of them get a really bad feeling. They're deeply, deeply concerned about the potential damage. But the way NASA as an organization responded to this, it was a world away from how they'd handled crises in the past. And this comparison says it all. You've heard of the Tiger team from Apollo 13, right? The best of the best, locked in a room, given total authority to fix a life-or-death problem. For Columbia, they formed what was called a Debris Assessment Team, or DAT. And it was, well, the opposite of a Tiger team. It was a makeshift group, they weren't sure who they reported to, and they had no direct line to the people actually in charge of the mission. The engineers on this team knew they were flying blind. The launch footage was just too grainy to tell how bad the damage was. They needed better pictures, and they knew that military spy satellites could get them. So the team's co-chair, a guy named Rodney Rocha, sends an email up the chain of command. And look at the words he used. He asks if they can petition, beg for help. The fact that he felt he had to use the word beg, that tells you everything about how powerless these engineers felt. So while the engineers were begging, this was the perspective from management. 5 days into the mission, Linda Ham, who was the head of the powerful mission management team, basically dismissed the whole thing. To her, it wasn't an urgent safety problem because they couldn't fix it in orbit anyway. She saw it as a turnaround issue, something for the ground crew to deal with after Columbia landed safely. 2 totally different realities. And that right there, that disconnect, led to the point of no return. Because the requests for images were coming through informal channels, and because there was no official rule that said they had to get images, management just shut it all down. The door to getting more data, the one thing the engineers were desperate for, was slammed shut. This is just heartbreaking. This is what Rodney Rocha wrote in an email after he found out his request was denied. He called the decision wrong and bordering on irresponsible. But here's the kicker: he never sent it. He later said that the culture at NASA was that you just didn't send messages like that up the chain of command. It wasn't done. You see, this is the crucial point. This wasn't about one bad decision or one manager. The communication breakdown, the way engineering concerns were just brushed aside, these were all symptoms of a much deeper systemic problem that had been growing inside NASA for years. The investigators had a name for this problem, and it's a phrase you should remember: normalization of deviance. It sounds academic, but the idea is simple. It's what happens when something that's clearly wrong, like foam falling off the tank, happens over and over again. If there's no catastrophe, you slowly, unconsciously start to accept it. The deviation becomes the new normal, and you stop seeing it as a risk. And you can literally watch this happen with the foam strikes over the decades. I mean, look at this. After the very first flight, it was a big deal. By 1990, NASA officially calls foam a safety of flight issue. That sounds serious, right? But then, shuttle after shuttle kept landing safely, even with foam strikes. So the classification gets downgraded. By 1992, it's just an accepted risk. And then, right before Columbia, after the worst strike they'd ever seen, it gets demoted to a simple action item. The problem was getting worse, but they were treating it as less and less of a threat. This whole way of thinking basically culminated in a single, fateful PowerPoint slide. Seriously, this slide is from the review for the mission that flew right before Columbia. They had just analyzed the most severe foam strike to date, and what did they conclude? The ET is safe to fly with no new concerns and no added risk. They had clear data showing the problem was getting worse, but their conclusion was that everything was fine. It's a classic, and in this case tragic, case of confirmation bias. So after the tragedy, the Columbia Accident Investigation Board released its final report. And to say it was stunning is an understatement. It was a deeply critical indictment that went way beyond just a piece of foam. To really drive their point home, the board ran a test that became the smoking gun. See, NASA had always assumed that foam was just too light and flimsy to seriously damage the wing. So the board said, okay, let's test that. They basically built a cannon and fired a 1.7-pound piece of foam at a wing panel at over 500 miles per hour. The result was jaw-dropping. It blew a hole through the panel big enough to stick your head through. In that one moment, decades of NASA's assumptions were completely shattered. And this is probably the most damning conclusion in the entire report. The board stated, in no uncertain terms, that the institutional failures, the cultural problems that led to the Challenger disaster in 1986 were never actually fixed. That NASA's broken communication, its flawed decision-making, it was all allowed to happen again 17 years later. And all of this leads to a final, really difficult question that the tragedy forced everyone to grapple with. When a system fails this badly, who is actually responsible? You know, two really opposing views came out of this. You had the systemic view from sociologists like Diane Vaughan, who argued that the culture at NASA was so broken that if you just swapped out the people, the next person in line would be forced to make the same bad decisions. But then you had people like Senator John McCain, who took the leadership view. He said it was infuriating because decisions aren't made by machines, people make them, and those individuals have to be held responsible. Ultimately, the Columbia disaster was more than just an accident. It was a profound lesson. A lesson that's relevant way beyond the world of spaceflight in any big company, hospital, or government agency. It forces us all to ask this really fundamental question. In any complex system, where does the responsibility of the individual stop and the responsibility of the system begin? That's the question Columbia leaves us with, and it's one we're still wrestling with today.